class 6 portion. But here something more related to the topic we will learn. So today we will discuss the representation of compound. How we will represent the compound. Means, suppose we are writing the formula. Suppose let us take an example, magnesium chloride, MgCl2. Means how we are deriving the formula of magnesium chloride. Sodium chloride, NaCl. How we are deriving, okay, that formula for sodium chloride. Carbon dioxide, CO2. So many formulas we are writing, but how we can derive that formula? How we can know that in sodium chloride, chlorine will contain 2 as a valency. Okay, so that we will see today how we can derive the formula. So here, better to tell you that this topic is how to derive a formula. So here I have written some steps. If you all have remembered, already these steps we have done in our class 6 portion. So little bit modification I will tell you. Okay. So you can see I have written here 4 steps to derive a formula. The first step we can see here, formula for the 2 parts written side by side. 2 parts means, suppose here I was talking about, suppose sodium chloride. Sodium chloride contains 2 parts. One is sodium and another is chlorine, isn't it? Magnesium chloride, suppose if you will take an example, it will also contain 2 parts. One is the magnesium and another is the chlorine. Okay. So here the first thing we have to do is that the 2 parts can be written side by side. And one more thing, remember, we have done already what is cation and what is anion. What is cation? Cation means those atoms or those ions which contains positive charge, and anion means those ions which contain negative charge. Means when we are talking about the 2 parts, then remember 2 of them, one must be a cation and another must be an anion. Always, most of the time, the first one is the cation. Here in MgCl2 also, the Mg is the cation and Cl2 is the anion. Okay. So here, just remember that whenever we are talking about the 2 parts of an atom, means one part must be a cation and one part must be an anion. So here, instead of writing this, what we can write? Formula for the 2 parts, that is, we have to separate the cation and anion. We have to write the cation and anion separately. Okay. So let us start with the first step. Okay. So here I have taken the example iron 3 carbonate. So here iron in bracket I have written 3. Why? Just now I am explaining. See, whenever we are talking about iron, then iron can be its multiple ionic states. Means iron can be formed Fe2 plus. Okay. It can form Fe2 plus or it can form Fe3 plus. Means iron can give 2 electron or sometimes it may give 3 electron. So when iron will lose 2 electron, it will be in its Fe2 plus form. And when iron will lose 3 electrons, it will be in its Fe3 plus form. So this is called ferrous. And this is called ferric. So, like this, iron has its multiple ionic states. Means iron can lose, sometimes it can lose 2 electrons and sometimes it can lose 3 electrons. So when it will lose 2 electrons, it can be represented as iron 2 plus. When it will lose 3 electrons, it will be represented as 3 plus. Already we have discussed about it in our last video. Okay. So here we are talking about the iron 3 plus. Means here this iron will lose how many electrons? 3 electrons. That's why here in bracket 3. So sometimes you may also find like this will be written iron in bracket 2. Means it will be about ferrous we are talking. Okay. So here we are talking about what? Ferric carbonate. Iron 3 carbonate means ferric carbonate. Okay. So let us start with our first step. So what we have to do? We have to separate the 2 parts. So here if I will write FeCO3 will be the formula of iron 3 carbonate. Okay. So we have to derive this. Means how we can get FeCO3. CO3. Okay, we can separate the two parts of the formula, that is iron carbonate or ferric carbonate, because here in bracket I have written 3. Fe3 plus means it is ferric. Okay, so the first step is over. Here we have separated the two parts of the formula. Okay, now step 2. Valencies are interchanged. So to interchange the valency, we have to first write the valency. Okay. So the second step is, first we will write the valency, then we will interchange the valency. So here the valency of iron and carbonate we will write. Before going to that, let me tell you the third step. Polyatomic ions are enclosed in bracket. Polyatomic ions are enclosed in bracket means, here if you can see, Fe is not a polyatomic ion because Fe or iron is a single element. But if we will move on to CO3, okay, CO3 is the combination of carbon and oxygen. 1 carbon and 3 oxygen means this is a polyatomic ion, CO3 minus. As I said, CO3 is an ion. So here this is a polyatomic ion, or else what we can say? This is a radical. Okay. So sometimes a formula may contain one element and one polyatomic ion. Here Fe is the element and CO3 is the polyatomic ion, or CO3 is the radical. Here we can see. So if it contains, so sometimes it may not also contain, see here, MgCl2, both Mg is one element and Cl is one element. So it is not a polyatomic ion. It do not contain any polyatomic ion. NaCl, it also do not contain any polyatomic ion. But if we are talking about this formula, iron 3 carbonate is a polyatomic ion. We can represent this as CO3 minus. Okay. So here, while deriving, need not to write the charge. Okay. You need not to give the charge of the element or its polyatomic ion. So here in the third step, what is written? Polyatomic ions are enclosed in brackets. Means if we got the polyatomic ion and we are writing the valency, then we will enclose it in bracket. So here we can write it. Step 3, Fe, we need not to enclose it in bracket because it is not a polyatomic ion. What is the valency of Fe? Here as we are talking about iron 3 carbonate, the valency is 3. It can donate 3 electrons. And what is the valency of carbonate? 2. Okay, so already we have talked about valency. The capacity to gain or the capacity to lose is known as its valency. So iron here, ferric, can lose how many electrons? 3 electrons. So the valency of ferric is 3 and carbonate is 2. Okay. So here let us do our second step only. Valencies are interchanged. So we will interchange the valency. So if we will interchange the valency, what we can get? Fe2 CO3 whole 3. Is it? So here we have interchanged the valency of iron and carbonate. Already we have done it, if you all are reminding. So this is the interchange valency. Now let us move on to the step 4. The charged valencies are divided by HCF, highest common factor. Okay. So here the interchange or the exchange valency. Here we have exchanged the valency. Fe got 2 now and CO3 got 3 now. So now we have to divide it by their highest common factor. What will be the highest common factor of 2 and 3? Obviously 1. 1 will be the highest common factor of 2 and 3. So if we will divide each, if we will divide it by 1, we will get the same result. Means we have the formula Fe2 CO3. Okay, so here we got the formula of iron carbonate Fe2 CO3O3. Okay, so here we have derived the formula of iron carbonate. Okay, so this is the step we have to follow. In case of polyatomic iron, we have to give or we have to enclose it in bracket. So these are some steps by which we can derive the formula. So this is the first example we have discussed. Now let us move on to the second example. Now let us move on to our next example, that is magnesium chloride. Okay, so here we will talk about the second example, magnesium chloride. So here the same step we will repeat. Okay, so step 1. We have to write the two parts of the formula as I said. What are the two parts of the formula? Magnesium and chlorine. Here, remember here I am not writing the formula. After deriving, here I will represent the formula. So what are the two parts of magnesium chloride? Magnesium and chlorine. So let us write magnesium and chlorine. Both these are the two parts of magnesium chloride. Step 2. We have to write the valency. Okay. Magnesium got its valency. If you remember the valency table, then just remind of that. What is the valency of magnesium? The valency of magnesium is 2. What is the valency of chlorine? The valency of chlorine is 1. Okay. So magnesium got its valency 2, means magnesium can lose 2 electron and chlorine can gain 1 electron. So here which one is the cation? Magnesium is the cation. Okay. And which one is the anion? Chlorine is the anion. Here just to show you I am giving the ion, a positive or negative sign. So while representing the formula or while deriving the formula, do not give any sign. Okay. No need of giving any sign. Just remember that you have to separate the cation and anion. Okay. So here the cation is magnesium and anion is chlorine, because magnesium will give 2 electron and chlorine has the capacity to gain 1 electron. So why magnesium will lose 2 electron? To get stabilized, to have the outermost electron or outermost cell. It should have 8 electrons in its outermost cell. But chlorine can be stabilized by gaining only 1 electron. So already this part we have discussed. I am not going through details. So here the valency of magnesium is 2 and valency of chlorine is 1. Step 3. Okay. So if we talk about step 3, then we have already discussed if it is a polyatomic ion, then we have to enclose it in bracket. So just think about it, whether it got any polyatomic ion or not. Magnesium is a polyatomic ion? No. Chlorine is a polyatomic ion? No. So we do not have polyatomic ion here. We got simple 2 elements, magnesium and chlorine, because here it do not have the polyatomic ion. Means in the earlier classes we have discussed about CO3. It is a polyatomic ion which is a combination of carbon and oxygen. But here we do not got any polyatomic ion. So need not to enclose it in bracket. So simply what we will do? Simply we will interchange the valency. So after interchanging the valency, what we can write? Mg1 and Cl2. Now in the last step, what we will do? We can divide each of the interchange valency with its highest common factor. So obviously what will be the highest common factor of 1 and 2? 1 only. So the same result we can get. So the result will be MgCl2 only, and remember need not to write 1 here, because if you will not write 1 also, it is the same, it represents 1 only. So here we will write MgCl2. So the formula of magnesium chloride will be what? MgCl2. MgCl2 is the formula for magnesium chloride. Like this you have to derive. Now let us move on to the next example. So students, let's talk about our third example, that is iron 2 sulfide. So here, remember here I have written in bracket 2, means it is ferrous. Ferrous sulfide means here in this case iron can lose how many electrons? 2 electrons. Okay, that's why here in bracket I have written 2. So what may be the formula we can write? FeS. So the 2 parts of iron sulfide may be Fe, that is the iron, and S, ferrous and sulfur. Okay, so here start with the first step. So the same, here we have to write the two parts. We have to separate the two parts of the formula. Ferrous and sulfur. Okay? Or iron and sulfur. Now, step 2. Here which one is a cation? Fe, as I said. Okay, the first one always is a cation. Okay, it is the cation and it is the anion. So we have to separate the cation and anion. Step 2. We have to write the valency. What is the valency of ferrous here? Obviously 2. In bracket I have written 2. It can lose 2 electrons. What is the valency of sulfur? 2. Whether it got any polyatomic ion? No, it do not got any polyatomic ion. Only simply we got 2 elements, ferrous and sulfur. Okay, so did not to enclose it in bracket. Got it? Now, step 3. We will interchange the valency. Okay, same only we will get because both got the same valency. Step 4. We will divide it into its highest common factor. What will be the highest common factor of 2? Tell me, what will be the highest common factor of 2? 2 only, isn't it? So here we will divide it into its highest common factor. Here I am showing this only to make you understand. Need not to write this also. Directly you can write the number whichever you will get by dividing. So what we can get here? Fe1 and S1. But as I said, need not to write 1. If you will not write anything also, it will represent 1. So what is the formula of ferrous sulfate? FeS. Okay, FeS is the formula of ferrous sulfate. So here some of the examples I have given. Some more examples are also there in your book. Don't worry, I will also give you assignment to do some more example of the interchange or to derive the formula. Okay, so here you have to follow the steps. Okay, step by step we have to do. All the things already we have done. Only the new thing for you is the step 3, isn't it? The polyatomic ions are enclosed in a bracket. Okay, because in class 6 we have not done about polyatomic ion. There something easier steps we have done. Here little bit more, little new step you have to follow. So this is all about how you derive the formula. Again go through the topic. Again try to solve some more formula. Again try to find out some more formula. You will find it